on, guys. We have this question right here. It's asking if the roller at A and the pin at B can support a load up to 4 kilonewton and 8 kilonewton respectively. Determine the maximum intensity of the distributed load W measured in kilonewton per meter so that failure of the support does not occur. So let's see how we can solve this question. So first of all, we had to put the forces acting on it. So first of all, we are going to have a, right, so they are saying A is the roller and B is spin. So A is going to have one force right here. Since let's call this one AY, and B is going to have two forces, BY and BX. So since we have to calculate A and B, so A is, let's say this is AY is going to be just A, and to calculate B I have to take the middle one. So this is going to be B. So to find that, it's simply B is going to be equal to Bx square plus By square. So this is how we can find B. So first of all, let's see what we can solve. So in this case, we have two unknown, um, three unknown, and we have too many unknowns here. Like Bx, we don't know Bx, we don't know By. Let's not write this one for now. Okay. So we have By unknown, Bx unknown, and Ay unknown. So first of all, and before I take the I can take the moment around A to cancel these two, but before I do that, let's see this one. This is equally shared force right here, so I can take one force that's acting on the middle. So to do that, I had to, let's say this is F. To calculate that force, I have to, this is like a square, so I have to take the area of the square, uh, area of this rectangle. So it's going to be length time the height. The height is W and the length is 4, so this is going to be 4W. F is going to be 4W, and let's put it as a one force in the middle. So I raise this one. So this arrows mean equal force is acting on it, so we can put it in the middle. So let's put it as F. So it's going to be exactly in the middle, and this is F. This is going to be 2 meter distance. So this is F. Now we can find the moment around B. Moment around B. So if I take moment around B is 0 in statics, and if I take counterclockwise positive and solve for this one, it's going to come out to be F is acting counterclockwise and F times 2. F times 2. Then we have AY acting on it. So first of all, so AY is acting on it. It's perpendicular to this one, and it's acting clockwise, so it's going to be negative AY. Now we have to know the distance to calculate this distance. So this is AY, and this is going to be the distance, right? To calculate this distance, what I can do is I can use cosine law. So let's draw this triangle separately. So we have two sides, 3, 4. We have two sides, and we can calculate this angle because this is a straight line, and if this is 30, this should be 150 to fulfill that 180. So this is going to be 150, and let's say this is C. So we have two side known and one angle known. This means I have to use cosine law. So cosine law, I'm using cosine law here to find this side. So C square is going to be equal to 4 square plus 3 square minus 2 times 4 times 3 cos 150. So if I calculate that, I will get C is equal to 6.77 meter. Then let's so this is going to be multiplied by 6.77, and those are the two moments we have, so this is going to be equal to 0. And if I calculate a comes out to be, let's say this is a comes out to be 1.18, and I substitute this 4w for f, so I get the answer in terms of w. So if I calculate this, I will get 1.1 w, 1.18 w. So this is the answer for a. Then what we can do, so since we have a here, a is, so a here, we can find one of these component. So we can take vertical or horizontal. Let's start with the horizontal one. Sigma fx is equal to 0 in statics, and if I take this one, this side positive, bx is going to be negative minus bx. Then we have a acting on it. We have to know this angle, so let's see. So if I take this triangle right here, if this is 30, this is going to be 60. If this is 60, this is making 90 degree with this one, so this is 60, this is going to be 30. Then we know it's 30 degree, and we have to find horizontal component. Therefore I have to take a sine 30. So this is going to be positive direction plus a sine 30. So if a is already known, 1.18 sine 30, and I will get Vx is equal to 0.591 W. So this is the answer for Bx. Then I can take a vertical component to find the y, a by. So sigma Fy is equal to 0 in statics, and if I take opposite positive and then solve for this one, this is going to be positive By. Then we have a acting on the, also we have f acting downside, so we have to put minus f. Then we have a acting upside, so it's going to be a cos 30 plus a cos 30. So I can substitute 4w for f, and for a I can substitute 1.18, and if I substitute and find the value, it comes out to be by is equal to 2.98 W. So this is the answer for by. Then I can calculate b by using this one. B is going to be equal to square root of 0.591 square plus 2.98 square, which is going to give me b is going to be equal to 3.03. So this is the b, and this is w, right? And this is the b we got. Then from this one, so we have a, we have b, and the question is asking if the roller at a and b pin b support load of 4 kilonewton and 8 kilonewton respectively. So it means they are saying a is supporting 4 kilonewton, b is supporting 8 kilonewton, and respectively determine the maximum intensity distributed load W measured in kilonewton per meter, so that failure of the support does not occur. So let's see how we can calculate. So first of all, if I equalize this one, 8 kilonewton equal to 3.03 W, and find the W. W is going to be equal to 2.64 kilonewton per meter. Then if I substitute here for A, this is for B. For A, if I substitute this one, so 1.18 W equal to 4 kilonewton. The W is going to be equal to 4 over 1.18. So this is going to be equal to 3.39 kilonewton per meter. So we have to choose the lowest possible. We have to choose this one because 2.64. You may ask what happens. This is also below, like we have 4 and 8. This is also below 3.39. So why we are not taking it? That is a good question, because what's going to happen is they are saying this should be the maximum thing, right? So when you if you find W is equal to 3.39, if you apply for this one, this is let's say for this one, for which one we have a 1.18 W and we have 3.03. Okay, for 3.03, if you apply this one, 3 times 3, it's more than 8, so it will break. So that's why we shouldn't take the biggest value. We have to always select the lowest value. So if you apply this one, 2.64, it's going to be below than 8 kilonewton, right? So that's why we choose this one. So this is the best answer. This is not going to happen. So this is the answer for this question. I hope you guys like this video. See you next time. So the final answer is W is equal to 2.64 kilonewton per meter. So thank you for watching, guys. See you next time.